Okay, so we're going over limits and continuity. And we're looking to see if this function is continuous. So we're going to try to sketch this from the information. Now what we have here is a piecewise function, right? F at x is this function, so f at x is equal to this when we're under this condition. So when we are equal to or less than -4. F at x then turns into this condition when between these two x coordinates and this condition when here. So one of the things we can do is essentially test at all those breaking points. So at our -4, right, and our +3. And what we're looking for is values from between them. So when we're looking at -4, because it's the first two of the piecewise functions, we're looking for those values at -4 to be the same. That would mean they're continuous. Same idea at the value of 3. We test it with D2. And if their y values, or if their f at x's are equal at that point, then we have a continuous function. But if we have a difference between the two, then it's a discontinuous function, right? So it's essentially just testing this. And one way we could do this is by graphing each of these within these ranges, but we can try it algebraically first, and then we'll graph it to verify. So the first idea is f at x is equal to x, and we're going to look at f at x, or we're actually going to look at f at -4, okay, which would be equal to, well, -4. So we know right away that f at x is equal to x. So when x is -4, f at x is equal to -4. Well, what that then means is, and because technically this function only exists at -4.0000001, the next value would be f at x is equal to 5. And we would test f at, let's say, -4, or sorry, not -4 because we're moving to the right, -3.99999, -3.999, something like that, extremely close to -4. And do you know what it would equal? Because the function is 5, it just equals 5. There's no change. So already, it's very obvious to tell that this is discontinuous. Right. These two are not connected because we were looking for a value of essentially almost -4 or -4. So these are very disjointed. We might as well test the other two, okay, with that same idea. So we'll call that our first pairing. What is that in yellow? So our first pairing was these two. And our next pairing, let's zoom in again, extend the page. Well, f at x is equal to 5. And we're going to test when f at x is 3. So when x is the value of 3, f at x is still 5. Nothing changes here because there's no x to plug in. And in our other function, f at x is equal to x squared minus 4. When f at x, when x is a value of like 3.00001, so just a little above that, what does our function become? It's almost equivalent to say what is our value at -4, or in this case 3. We can essentially plug in our value of 3 because we know we're going to be extremely close to where our 3 is. So if we plugged in 3, or 3.0001, we're going to say approximately 3. So we plug 3 in there, we would get 3 squared minus 4. And that gives us 9 minus 4, which gives us a value of 5. So there, at this point, or at this junction in the piecewise function, we would probably have continuity, but we don't at this point here. So we're going to go to our graphing calculator Desmos. I should really prep that a little better. And we plug in our functions. So we have x, and we're going to actually put a domain on it. X when, and what's good about this program is we can put domains and ranges on these functions. So x when, what do we say? X is less than and equal to 4?
Yeah, -4.
-4, that's right. -4. So there we go. It's actually drawing our function. It stops at that exact point. The next point was we were the value of 5. And I might have to write y equals 5, or f at x. F at x is essentially our y value. When we are greater than 4, but less than and equal to the value of 3, Okay, so right there, this is showing you that here's our value of 4, and then this is our jump. This is our huge jump in the function, right? So our piecewise is discontinuous here. And then we type in our last equation, which was x squared minus 4, I believe, right? Minus 4. But they were also in the range of anything greater than 3. So that's only when x is greater than the value of 3. And it just so happens that if we go there and you almost, sorry, wrong way. If we zoom in, this looks continuous, and it essentially is. This would be continuous here, though undefined at the exact point. Well, that's the purple one. In the green one, it is defined at that point. And then from there, it takes off into the red one. So this would be continuous there. But we're very disjointed at our value of -4. That point there is disjointed, so it is discontinuous, this function. In order for it to be continuous, I would be looking for a linear equation that essentially needs to go way higher. So if they give me something like, I'm just going to test one out here. It's 5. I need a little more. 9. Hey, there we go. If that had been our function, x plus 9 instead of just the value of x, then we would have been a linear here, and then technically linear again, just a horizontal line, and then we turn into a quadratic, but a continuous function nonetheless. Okay, so what we discovered that this is not continuous, this piecewise function. Okay, does that make sense? Mm-hmm.